In this lesson, we are going to discuss the effect of dilution, and we are going to be able to model them molecularly to show that. So, first off, a dilution is just when you add more solvent to a solution, and that has an overall effect of decreasing the concentration. Now, you are well aware of this, anyone who has ever made lemonade from a concentrate. Concentrated lemonade is very sour, and it's pretty gross. It's too much, too concentrated of a solution. So what we do is we add it to some water. So we increase the volume by adding more solvent. In most cases, in our class, the solvent's going to be water. So what we do is we increase the volume to decrease the concentration. So by adding more solution, what you do if you look up here at the molarity formula, molarity is just moles of solute over liters of solution. So if I just add water to it, my moles are the same. My moles are the same, but my volume increases. So if I'm dividing by a bigger number for my molarity, therefore I should have a decreased concentration. Let's do some molecular modeling with this. Let's say we have a half a liter of solution, and let's say that each X is representing 0.1 moles of solute. We'll say, it doesn't matter really the solute. So let's say I have 5 of those in solution. So my molarity is going to be equal to 0.5 moles over 0.5 liters. So that's equal to 1.0 moles per liter. Let's say to this solution I add 1.5 liters of H2O. So I still have the same amount of solute. I've just increased the volume. So if I add 1.5 liters to 0.5 liters, I ultimately have 2 liters overall. So my molarity in the end is 0.5 moles over 2.0 liters, giving me a molarity of 0.25. So you can see how my concentration decreases here. Let's check if this makes sense using our dilution formula. The product of M1 and V1 is equal to the product of M2 and V2. So my initial molarity is 1.0 moles per liter. My initial volume is 0.5 liters. Does that equal my final product? My molarity 2 is 0.25 moles per liter. And my final volume is 2 liters. So 1.0 times 0.5 is 0.5 is equal to 0.25 times 2 that's 0.5 as well. So yes, it does work out. Now the reason why is because moles are the same. Remember, that holds true because I'm not adding any more moles of solute. I'll say that. Moles of solute are the same. And that's it for this one. This is a quick one, guys. So, good work. And we'll be using this. This is a common one that if you ever go into any sort of lab work, lab tech, you'll be seeing these. So, we'll get to know.